Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to discuss the details of hydraulic accumulators. If you are not subscribed, kindly subscribe my channel, and if you are already subscribed, kindly comment and share. In this session, I am going to discuss what are the hydraulic accumulators and how accumulators are classified and working of hydraulic accumulators. Later, I will take the advantage and disadvantage and applications of hydraulic accumulators. Hydraulic accumulator is a device that stores hydraulic energy, allowing a hydraulic system to cope with sudden or intermittent demands using a smaller pump. Is smoothing out pulsations and compensating for leakage or pressure drops. Function and purpose: energy storage. Accumulators store hydraulic fluid under pressure, acting as a reservoir of potential energy. Peak demand: they can supplement the pump during periods of high demand, allowing for smaller pumps and reduced energy consumption. If the demand peak demand is there, we cannot use the higher capacity pump for all the periods. And for that accumulator, if you use, that can supply the additional power required during the particular time period of peak demand. Okay, there even though we can use the smaller pumps there. Pulsation dampening. Almost this one, pulsation output will be produced from the most of the hydraulic pumps. Particularly, reciprocating pumps produce more pulsation supply, and there that pulsation will be dampened, and that will be reduced, and continuous supply from the pump we can achieve by using the accumulators. Accumulators can smooth out pulsations and vibrations in the hydraulic system, improving performance and reducing noise. Pressure maintenance: they help to maintain a consistent pressure level in the hydraulic system even during fluctuations in demand. The whatever the variation in the pressure is taking place during the fluctuation in the demand, the constant pressure is maintained by the accumulators. Shock absorption: accumulators can absorb shocks and vibrations, protecting hydraulic system and connected components. Here the shocks are producing during operation. Those are due to the variation in the flow and the operation of the various hydraulic systems like pumps and the actuators. There the shocks will be produced, and those shocks will be absorbed by using these accumulators. Leakage compensation: they can compensate for fluid leakage or pressure drop, ensuring consistent performance. If any leakage is there, that much quantity of the fluid will be lost from the system. That additional the flow of the fluid what is required, that can be supplied by the this accumulators. And even though that due to the leakage, the drop in the pressure is taking place, and the pressure drop that also can be compensated by the accumulator. Types of accumulators: first one, gas accumulators. Those are called as a hydropneumatic. The fluid pressure is maintained by the gas. That's why it's called as a hydropneumatic. These are the most common type, using compressed gas, typically nitrogen, to pressurize the hydraulic fluid. The gas accumulators are classified into three types. First one, bladder accumulators. Feature a flexible bladder separating the gas and fluid compartments. Piston accumulators use a piston to separate the gas and fluid compartments. Diaphragm accumulators employ a diaphragm to separate the gas and fluid compartments. Continuation with the type of accumulators, there are another two. Spring accumulators use a spring to apply pressure to the hydraulic fluid. Weight accumulators use a weight to apply pressure to the hydraulic fluid. That is also called as a dead weight type of the accumulators. Here This one is the first one, dead weight type of the accumulator. By using this weight, the pressure will be applied. When the pressure increases, the fluid will be stored here, and that is the weight. And whenever the pressure decreases, that fluid will be supplied. And by using the spring pressure, that also it will be the fluid will be pressurized in the system. These three are the gas uh, accumulators. The three types, there is a bladder type, piston type, and diaphragm type. Working principle: when the pressure in the hydraulic system increases, the accumulator absorbs the pressurized fluid, compressing the gas in gas accumulators or compressing the spring in spring accumulators. When the pressure in the hydraulic system decreases, the compressed gas or a spring expands, forcing the stored fluid back into the system. And this principle of working what is there, we can explain by taking the one of the gas accumulator. Here, this is the gas accumulator of diaphragm type. And here, the pressurized gas will be there in this part. The other part, the fluid will be accumulating during high pressure. You can see that one at a higher pressure in the system. The hydraulic fluid will be accumulates and compress this gas in the downward direction. And when the system pressure decreases, and that needs the supply of the hydraulic fluid, that fluid will be as it is stored at a higher pressure, and due to that compressed air pressure, it will be supplied in the system. Then the fluid flow will be compensated any of the requirement of the system. Then advantages of the accumulators. First one, energy efficiency. By supplementing the pump during peak demands, accumulators can reduce the size and energy consumption of the pump, thereby increases energy efficiency. Fast response. They can provide a quick source of hydraulic power for rapid actions. Reduced pulsations. They help smooth out pulsations and vibrations in the hydraulic system that already I have discussed. System protection. They can protect the hydraulic system from damage caused by pressure spikes, leaks, and thermal expansion. Applications: hydraulic brakes. Accumulators can be used to store pressure for emergency braking. Hydraulic suspensions. They can dampen vibrations and shock in vehicle suspensions. Construction equipment used for powering hydraulic cylinders in construction machinery. Industrial automation used in various hydraulic systems for energy storage and control. Wind turbines used in hydraulic wind turbines for energy storage and recovery. This is about the hydraulic accumulators, and we know that one in most of the hydraulic systems we are going to use the hydraulic accumulators for their advantages. And what the different types of accumulators I have discussed as a classification. There's a gas accumulator, spring type accumulators, weight type accumulators, and in the gas type also there are different types. Those working of those accumulators I am going to take in some other sessions. Thanks for watching. If you like, share, subscribe, and comment.